Okay, moving on to page 9, we've got examples 5 and 6, both of which use trig. So hopefully you remember how to differentiate trig from last lesson. Look back in your pack if you're not sure. So we're still using dy by dx is equal to dy by du times du by dx. We want to look for what functions inside another one. That's going to be our u. Meaning that y is equal to sine of u. Differentiate both of these, the easy one first. And then, okay, what do we do when we differentiate sine? Hopefully you remember that is cos. And then our final answer, we multiply those together. And in fact, I'm going to do example 6 as well, and then you can have a go at the u tries. I just pointed to those, which obviously you can see on the video. Anyway, okay, let's have a look at this one. So, let's just check what we've done so far. Function inside is 4x squared minus x. So that's our u, and that means that y is cos of u. We can then differentiate 4x squared minus x, and we get 8x minus 1. So I think this is the first time we've done an example where there's two terms there. That's perfectly fine. And cos, we need to remember, differentiates to minus sine of something. So cos of u becomes minus sine u. And so then we're going to multiply them together. dy by dx is equal to, so I'm going to put the minus sign at the front. The 8x minus 1 needs to be in brackets. It's the whole of that, not just one of those terms is going to be multiplied by the sine u. And obviously I'm not going to write u, I'm going to write the original function I had inside. Okay, so what again you need to do is make sure you've got those written down, and then you pause the video and write down, have a go at the u try. Don't just copy down the u try, actually have a go at doing it for yourself and then look at the answer. So pause the video. Okay, assuming you've paused it like you've been told. Here are the answers. You can check whether or not you've got them right. So for this one here, we've got minus 4 sine of 4x plus 7. For this one here, we've got 12x squared times by cos of 4x cubed plus 1. So what we notice with these is, again, the function inside stays the same. And what we've got there is we differentiate that function inside and put it on the outside. And obviously cos and sine differentiate in the way that they're supposed to. So you might want to stick with using the dy by dx up here. If you think, actually, no, I like to learn separate bits. So I'm going to write this down. I think this is one you might want to just stick to the rules. So let's look. Cos differentiates to minus sine. And we also need to differentiate the function inside. And sine differentiates to cos. And we need to multiply by what you get if you differentiate the function inside, just about fit that in. So again, there is a short exercise for you to have a go at doing to practice that kind of idea and hopefully start to get your head around that. And then we're going to look at some slightly trickier examples.